Hi, Jerry Lynn. Hi, Michelle. Hey, I worked out this problem for you in not in MATLAB, but in Excel. So I wanted to send this to you, and I'll send you this spreadsheet as well. But I did talk to Dr. Floyd, so this is what he had in mind. So what the deal is, where he says build a perfect matrix based on the expected matrix percent and the user input value. That's what he means for this formula, which is 1 minus 1 divided by e to the x. Now, that's where this expression is, and you can see this is what the equation looks like in Excel. So it will look similar in MATLAB, but I'm not exactly sure how it would be. But here's the value when I plug in 1 and 2 all the way down to 6, okay? Then since the test value is 9 for each of these points over here, each of these percentages, you multiply that value by 9, and these are the values that you get. Now this set 1, 5.689, etc., down to 6, 8.977691 are the perfect matrix values. They're perfect because they are based on an equation and what you would theoretically expect to get. So I've plotted those points, because that's the next part, and they're plotted here in blue. Now, when the theory is that when we did the experiment, we did 4 different test runs for each point. So in other words, these are the 4 values that tested that in a perfect world would have looked like this. And these are the 4 values that would have tested to look like this in a perfect world, and so forth. So there are only 5 points instead of 6 points. But each of these points has been tested 4 different times because the test has been run 4 different times. So when you take the average of each of those 4, that's what the equation looks like in Excel. You then take these averages, these 5 averages, and you plot them against points 1 through 5. There's only 5, not 6, but you get this gray curve. So what we're really talking about here is, what does the experimental average value, the gray curve, look like compared to the expected perfect value, which is the blue curve. So this is the result that he wants you to have to plot in MATLAB. So this is the work. The other thing is he specifies that he wants the plot to start at 0, 0, which I'm not sure. I think maybe MATLAB tends to start at 1, 1. So you have to reset the origin of that graph as well. But this is the work. This is the perfect, this where X is plugged in for 1, 2, 3, 4, 5, 6. And then whatever that number comes up to be is multiplied by 9. That gets plotted against 1 through 6. Then each one of these test runs has 4 values because there have been 4 tests run on each point. And those numbers get plotted against their test run, and then the 2 are compared in the graph. So I hope that's helpful. I'll send you this spreadsheet as well. And let me know how it works out for you. Good luck.